Hey friends, I'm going to make this video again because I made it once and it didn't save, so if I sound crabby, that's why. What we're going to talk about here is the end behavior of a graph. We've talked about the zeros and increasing and decreasing, and this is going to be what are the ends doing. And shockingly, the end behavior of a function describes how the function behaves, thus the name, as it moves infinitely to the right and left. The end behavior is what happens to the values of y as the x increases or decreases without bound. Here's kind of what that means. Let's think about the x and y axis. Here's x, here's y. As you go this direction, which is formerly known as the right, x is approaching positive infinity. As you head this direction on the x, which we used to call the left, x is going to be approaching negative infinity, because if you just think of the number line, these are increasingly positive and these are increasingly negative numbers. Then in a direction that we used to call up, we're now going to think the y or the graph or the function is going towards infinity. And if the graph is heading down, then we are going to think of that as heading towards negative infinity. So we're looking at what the ends of the graph are doing. So one of the things you have to learn is going to be this new notation for saying left and right, which ties into that diagram that I just drew, because this is our notation, and this would be read as the limit, meaning what it's going towards, of the function as x goes to negative infinity, and that would essentially mean the left end. Here, the right end is going to be the same concept, but it's the limit of that function as x approaches positive infinity. So that's what it's doing as it goes to the right. So you want to be able to read this and be like, oh, they're asking me about the right end, and then read this as asking you what the left end is doing. So that's an essential concept. I'm going to go ahead and highlight that in green because I need to know that later. And then we're going to do a few examples of writing that out. And by a few, apparently I mean a bunch. So here it's asking you, like, you can just use your eyeballs and say, hey, the left end of this is going up and the right end of this graph is going down. So I'm just using my eyes. This is asking me to describe the left end, and I would basically just say the left end goes up as x approaches negative infinity, which is essentially saying the left end. So the left end behavior in a limit statement, this is the thing that you really want to practice, that you would write the limit of this function as x goes to negative infinity, since you're talking about the left end, is, and then to say that it's going up, you would say infinity. So this is telling you what the y or the graph is doing, and the left part is telling you, like, this whole section is telling you whether you're looking at the left or right end. So when we go to look at the right end, which is going down, I'm going to say exactly that. The right end goes down as the x approaches infinity, which is our new fancy way of saying the right. So my limit of the function as x approaches positive infinity, because I'm talking about the right end now, and then to indicate that it's going down, I put negative infinity. So we really want to feel confident about writing these limit statements and knowing what they mean. This limit statement essentially says right side going down. This one says left side is going up. So same thing here with this new graph. In this case, both the left and the right are going up. And so I would just say that my left end goes up as x goes to infinity, as x goes to negative infinity, since it's the left end. And here I would write that in limit notation as the limit of this function as x approaches negative infinity, indicating the left end is going up, so positive infinity on the y side of my statement. The right end of this is also going up, so that's exactly what I say. Right end goes up as x approaches infinity, indicating I'm talking about the right end. In limit function, I'm going to have that the limit of the function as x goes to infinity is going up. And so again, this side is talking about the right, and this side is telling what it's doing, which is going up. Okay, here we're drawing a sketch. We're going to look at this and say they're talking about the left end is going down, and then here This is describing the right end going down also. So there's a bazillion and a half possible answers. I'm just drawing a polynomial function where both the left and the right go down. And then I'm done what they said. Those are the given end behaviors. Here, x approaching negative infinity is left. This tells me my y is going down. Here, my x's are getting larger towards positive infinity, so that's going to be the right end, and my graph is going up. So I need something with the left end going down and the right end going up, and you can draw any polynomial graph that you want as long as the left goes down and the right goes up. So that's kind of how that looks in graphic form. If you don't have a graph and you only have the function, you don't want to have to graph it to figure it out. So we're going to figure it out another way. For polynomial equations, it's easiest to find the end behavior of the right side first because the left side's going to follow. So these two concepts are super important to kind of know because it's what you just look at to tell you the answer. So the right side goes up if the leading coefficient is positive. Shockingly, the right side will go down if the leading coefficient is negative. You absolutely just want to know that because you're just going to look at it and it's going to tell you what the right end is doing. And then the left end is either going to go in the same direction as the right end based on the degree. So you're looking at a totally different thing. And if the degree is even, it'll go in the same direction. And it will go, shockingly, in the opposite direction if the degree is odd. So if you have a first term and you are looking at this leading coefficient, if it's positive, your right end goes up, and if it's negative, your right end goes down. Then you're looking up here at your degree to see if it's even or odd, and that'll tell you what the left end's doing. So the leading coefficient will tell you what the right end's doing, and then you look at the degree to see if the left end is doing the same or the opposite. So that's a super essential concept up here. Make sure that you are able to know those matchups when you go to do your assessment, and definitely when you go to do your AP test. So here, I'm not going to write it out in limit notation because it says limit notation is not necessary. So I'm going to look at my leading coefficient, which is a 4, but I don't care if it's 4. I just care that it's positive. That indicates my right's going to go up. My degree is 5, which is odd, so that the left will do the opposite thing. Here, I look at my leading coefficient, which is positive, so right goes up. I look at my degree, which is even, so left does the same. This one I'd have to multiply out, and I'm not going to take that times itself 6 times, but I do know I would end up with negative 2x to the 6th as my leading term. So since my leading coefficient's negative, the right goes down. Since my degree is even, the left does the same. Here, be cautious because this is actually the leading term. If it was written in proper standard form, it would look like this. My leading coefficient is negative, so the right is going down. My degree is odd, so the left is doing the opposite. Here you have to be careful too because this should be the leading coefficient, the leading term, because it has the highest degree. So my leading coefficient is positive, my degree is odd. So leading coefficient positive tells me the right end's going up, and my odd degree tells me the left end's doing the opposite. So make sure you look to see which of those terms has the highest power. This is not multiplied out, but if it were, I'd have 2x times this x and then times this negative x. So my leading term would end up being negative 2x to the 3rd. So my leading coefficient is a negative, so the right's going down. My degree is odd, so the left is going to do the opposite. So that's without limit notation. This is simply saying to write the limit statements. I'm going to still think about it in the same manner. I'm going to think my leading coefficient is negative, the right end goes down. My degree is even, so the left end does the same. And then I'm just going to take time to write each of those in limit notation. So first I'm going to talk about the left end. So x has to approach negative infinity. And since it's going down, it has to be negative infinity for the y as well. On the right end, I would write that as the limit of the function as x approaches positive infinity. Since it's going down, I would have to write negative infinity. That should actually be for both of these. So this is telling me which end I'm doing. And then this is telling me if the graph is going up or down. And in this case, they're both going down. So I only, oops, how did I do that? Okay, so on this one, this is my leading term. My leading coefficient's positive. My degree is odd. So the right end's going to go up and the left is going to do the opposite. So when I go to write my right end limit statement, I'll say the limit of g of x as x goes to infinity to let everyone know I'm talking about the right end. And since it goes up, I'll use positive infinity over here. Left end down, I'd write the limit of that function as x goes to negative infinity to indicate that I'm talking about the left. And since that's going down, I'd have to use negative infinity on this side. All right, this one is going to be something that you'd have to do on the graphing calculator part of our test, so make sure that you are able to get these graphed. I would recommend that you stop the video and graph each one, and then make sure that what you see is what I have. So if you do this, type it into y equals. Make sure you're using x comma t comma theta comma n for your x, and then just do for a window. Sorry, I'm out in the hall, it's pretty loud. Go to zoom and then hit 6. Zoom is a button right under your screen, and then the number 6. That'll just give you normal graph paper from -10 to 10 in every direction. Try to do this graph and then look back on here and see if we get the same thing. If you're just copying mine, you're not getting the experience of doing it on your calculator, which you'll need for the test. Now I can use my eyeballs to see that the right end goes up and so does the left end. So when I write my limit notations, I can say the limit of this function as x goes to infinity, so I'm talking about the right end, goes up. And the limit of this function as x goes to negative infinity, so I'm talking about the left end, also goes up. Now, we have a little surprise sneak attack here at the end. When you graph this, if you have a new calculator, it'll display like a fraction. If you have an older calculator that doesn't display as a fraction and just looks like this, you have to make sure to use parentheses so it knows which is the top and which is the bottom. So again, stop the video, make sure that you've tried graphing this so that you can see on your own what this should look like. Okay, so if you get the proper graph, you should have 2 branches that kind of go close to these asymptotes. The asymptotes don't really show up on your calculator, but you can figure out where they are. So for the first time, our ends are not going up or down. This is the right end and this is the left end, and they're both approaching this number, whatever that is. So I look on my y-axis and I can see that that's a 2. So there must be a horizontal asymptote at 2. So when I go to describe that the limit of this function as x approaches positive infinity, which I'm talking about the right end, it's going towards 2. And the limit of this function as x goes to negative infinity, so now I'm looking at this end over here on the left, that part of the graph is approaching 2 as well. So they're not going up or down, they're getting close to 2. Take a minute to graph this function on your calculator. Make sure that you have it correct before you move on, so stop the video. If you graphed it properly, you should see something like this. And again, here's the right end of the graph and here's the left, and it's not going towards infinity. They are just going right up really close to the x-axis where y is 0. So the limit of the right end, so x approaching infinity, is actually going towards 0, and the limit of the left end, x approaching negative infinity, is also going towards 0. So these last two are just showing you that the ends don't necessarily have to go up or down, and you'll need your graphing calculator to help you look at that and establish the value. So that's going to be on that calculator required part of the test. Hope this helps.